Okay, so these are the solutions for the section on linear equations in two variables. So the first 5 problems, all we have to do is find the slope and intercept and plot the function. They're all linear functions. So we've got y equals 5x plus 3. So, basically, if you have a line in slope-intercept form, we know the y-intercept and we know the slope, and so we can get a second point. And once we have the intercept and a second point, or both intercepts, we can figure out what the curve looks like. So let's do it two ways. One, we'll find it. The y-intercept always is easy when you have it in slope-intercept form. So that's the y-intercept is when x equals 0, and when x equals 0, you've got 3. And then you've got the slope of 5. So we can plot the point, and all of these will do from -10 to +10. So we plot the y-intercept. So x equals 0, y equals 3. And you have positive slope of 5, so that means you go over 1 and up 5. 1, 2, 3, 4, 5, like that. And so you have the 2 points, and you take a ruler and draw a line between those 2 points. And sometimes you can get thrown off. Sometimes it's better to have 3 points. So just to show you this, if you go to the right, you go over 1, up 5. If you go the other direction, you go 1 left, down 5. So 1, 1, 2, 3, 4, 5. So you can see that I've not drawn it quite right. So that would be the line, and then you can extend it out like that. So that would be one way of doing it. You can see so you can see that the x-intercept's between -0 and -1. Let's just show you how that works. So to find the x-intercept, you set y equal to 0. So you get 0 equals 5x plus 3, or x equals -3/5. So in some ways that's problematic because it'd be hard to plot that exactly right. So in this case, it's probably better to plot the y-intercept, which is easy to plot points right on the grid, and then use the slope to find a second or third point. Okay, the second one is, it says it's a linear equation in two variables, but in reality there's only one variable, but you can still plot this. So you divide both. Well, what you do is you subtract 5 from both sides. So I forgot to write the original equation. So you subtract 5 from both, divide by 3. So you get y equals -5/3. So this one easy. It says you have the same y value for any value of x. So all we have to do is find the y value, just draw a horizontal line. So 5/3 is 1 2/3. So we'll just so all we have to do now is find -5/3, and if we go down to -1, -2, -5/3 is there, and then we just draw a horizontal line at that value y. So that's the line y equals -5/3. Problem number 3. So this equation is in what we would call standard form. So that's when you have some constant times x plus some constant times y equals 30. And it's really not in a form that helps you out relative to plotting it. You could calculate the x and y intercepts from this form, or you could put put it in the slope-intercept form, so I think I'm going to do that. So first thing you would do is you would subtract 7x from both sides to eliminate 7x on the left-hand side. So you'd end up with negative 7x plus 30 equals 6y, and then divide both sides by 6. So you divide 7 by 6, divide 30 by 6, which is 5. So again, we're in the slope-intercept form. So the y-intercept is going to be equal to the point 0, 5, which is, again, easy to plot on this Cartesian system. So that's going to be 1, 2, 3, 4, 5. So that's the y-intercept. And then you've got this negative slope of 7 over 6. So you're going to move 6 in the horizontal and 7 in the vertical. And one's going to be positive and the other one's going to be negative. So let's just go, this is the delta y over delta x. So you go 1, 2, 3, 4, 5, 6. So that's the x change, and then you go to negative 7. 1, 2, 3, 4, 5, 6, 7. So that's your second point. And the further 2 points are apart, the easier it is to draw a reasonably good curve. So I'm going to start here, and you would take your ruler and just put a ruler between the 2 points, draw a straight line as possible. And I think the way the scale is on this thing, that the next point that is an intersection of 2 grid lines is going to be off the grid. So we probably would just use those 2 points. But again, the slope, slope equals rise over run. So that rise is the y. That's why we go 1, 2, 3, 4, 5, 6, 7. And the run is 6. 1, 2, 3, 4, 5, 6. Negative slopes go like this. Positive slopes go like that. Okay, so that's number 3. 4 is the other example of only having one variable. So if you solve for x, you'll get x equals negative 5. So this is a vertical line. When you have y equals something, it's a horizontal line. X equals something, it's a vertical line. So that's, again, pretty easy to do. So all you have to do is find the next value equal to negative 5. So you go 1, 2, 3, 4, 5. And we just draw a vertical line. Not like that, but like this. And then the final one is another example of one that's in standard form. So if we make it into slope-intercept form, we'll subtract 3x from both sides. That'll leave you 2y is equal to negative 3x plus 7. Divide both sides by 2. You get y is equal to negative 3 halves x plus 7 halves. So we know the y-intercept is 0, 7 halves. So we can plot that on the graph. So we go 0, 7 halves. So 2 halves, 4 halves, 6 halves, that's 3. 1, 2, 3. 7 halves, right there. The slope is negative. Now, in this case, you could, go over 3 and down 2. Actually go down 3 and over 2. So let's do that. So we go down 3. The slope is 3 halves. So we're going to go down 3. 1, 2, 3. And over 2. 1, 2. So that would be this point right there. It's not the intersection of 2 points. So another possibility would be to let, say, x equals 1. And what that would do is it would give you a whole number. So x equals 1, plug that in, you get y equals negative 3 halves x, 3 halves x, which is 1, plus 7 halves. So that's negative 3 halves plus 7 halves, which is 4 halves, which is 2. So another point that's the intersection of these two would be x equals 1, y equals 2, which would be right here. And you can see it fits right in there. And then from that point, you could take a slope of negative 3 halves. So you go negative 3, 1, 2, 3, positive 2. So you see all these line up. So there's multiple ways of getting that. And again, these are pretty close to each other. So sometimes it's better to kind of keep going. So you go over 2, down 3, over 2, down, whoops, over 2, down 3, over 2, down 3. So you see I went way too low there. Right there, I think. Over 2, down 3, over 2, down 3. There we go. Over 2, down 3. So you can see I've got a pretty good curve there. So sometimes you want to go more than just one step, especially if the slope is close to 1, because you only go a small distance. So if you know, one way of approaching this would be to go over 2, down 3, over 2, down 3, over 2, down 3, over 2, down 3, and you'd have this point and say that point, and that larger distance between 2 points would give you a more accurate representation. Okay, so those are the first 5 problems. The second problem says plot the points and find the slope. So that's pretty easy. Not even asking us to graph them. So remember that the slope is defined as delta y over delta x, rise over run. But in terms of coordinates, y2 minus y1 over x2 minus x1. So if I give you 2 coordinates, 3, 2, and 5, negative 3, it's completely arbitrary which one is 1 and which point is 2. You're going to get the same answer. So I always just choose whichever one's first is x1, y1, whatever second is x2, y2. So that's just a matter of plugging now into the formula. So we have y2 is negative 3, y1 is 2, x2 is 5, x1 is 3. So here we have negative 3 minus 2, which is negative 5, 5 minus 3, which is 2. So the answer is negative 5 halves. So that's the slope of the line passing between these 2 points. And all that would happen is if you switch these two, you'd get probably 5 over negative 2, which is still negative 5 halves. And the second one, we have 2 points again, negative 4, 3, and 2, 3. So the slope equals y2 minus y1. So I'm just going to go over here and label them like this. So what we've got is y2, which is 3, minus y1, which is 3. Didn't realize. And then the denominator is x2, which is 2, minus x1, which is negative 4. So you get 0 divided by 6. 2 minus a minus is a positive. So the answer is 0. You don't want to show it 0, 6. You want to simplify it. You know, anytime you can simplify the slope, you want to go ahead and do that. Okay, the next set of problems is asking you to find the slope-intercept form given 2 points. So there's, well, I was going to say there are 2 ways. It's really just one way. the procedure is first you find the slope, and then you use the point slope form. And then once you use the point slope form, you then simplify it down to the slope intercept. Okay. So just like in the previous problem, we're going to calculate the slope first. But before we do that, let's write the 2 points down. And then label 1.1 and label 1.2. Okay, so we're going to call this x1, y1, call this x2, y2. So the slope is 5 minus a negative 1. And the denominator is negative 5 minus 5. So here you got 5 minus a minus 1. Well, that's positive 1, so you get 6. And here we have negative 5 minus 5, which is negative 10. You simplify it, so you can divide both the numerator and the denominator by 2, so you get 3/5, negative 3/5. So that's the slope. Then use the point slope form of the linear equation. Y minus y1 is equal to m times x minus x1. So you can use either this as x1, y1 or this one. It doesn't matter, just so you're using this correct corresponding 2 points. So I'm going to use this because that's already called x1, y1. You get the same answer either way. So you get y minus y1, which is negative 1. Slope, which is negative 3/5 times x minus x1, which is 5. So that's the point slope form of the linear equation. Now we want to get it in the slope intercept form. So the procedure is you do whatever you need to do here. So if it's just negative, some positive, then you just make it negative. If it's negative and negative, then it becomes positive. So it's going to be y plus 1. And then you distribute the slope to both terms. So you get negative 5/3 x and negative 5/3 times negative 5. So let's write that out. So we're going to have negative 5/3 times negative 5. Now you don't have to write this out if you can just do it in your head. You can see the 5's cancel out, negatives cancel out, you get plus 3. Okay, now the final step is you want to isolate y by itself. So we're going to subtract 1 from both sides. So that gives you y is equal to negative 3/5 x plus 2. So that's your solution for that problem. The next one, 2 points again. Okay. Slope. Oh, first thing you got to do is write this down. And the reason I do this is because that's a lot of times is the biggest problem. People get confused about what they're doing, which one is x1 and y1. So if you have the formula, which I have on a previous page, you can do it better. So we've got y2 minus y1 divided by x2 minus x1. So 7/2 minus 1/2 is 6.5, which is going to be 13/2. And negative 8 minus 2 is negative 10. So now we got to simplify this thing down. And one way to do this is to make this into a fraction. So negative 10 is the same as negative 10 over 1, and then you change the multiplication problem into a division problem. And you can see that would simplify down to 5. Well, it's got a pretty high slope to it. So that's negative 65. Now at first that seems very big. It's because I did it wrong. Okay. That's one reason I leave my errors in here, just to, they just seem way too big. So I forgot I did the reciprocal the wrong way here. So the reciprocal of negative 10 is 1/10, negative 1/10. Okay, now we can do it. So what you end up with is negative 13. 13 times 1 is 13. 2 times 10 is 20. So that's the slope. Okay, so now we use the point slope form, linear equation. So y1 is a half. Now, in this case, because this is a half, I might choose this one because they're whole numbers. But let's just go ahead and use it anyway, see what happens. So you get a half. The slope is negative 13/20 times x minus x1, which is 2. So you distribute the negative 13 over 20. So you get negative 13 over 20x. You'll see here that 2 over 20 is the same as 1/10. So it'll be 13/10. So what it is, you've got 26/10, which reduce it down to 13/10. You got a negative times a negative, so it's going to be positive. Now all we have to do is add a half to each side. So you get y is equal to negative 13/20 x, and then you have 13/10 plus 1/2. You need to find a common denominator. So the common denominator would be 10. So you get 13/10, and this would be, you multiply the numerator and the denominator by 5, so you get 5/10. 13 plus 5 is 18. And then you can simplify 18/10 by dividing both the numerator and the denominator by 2. So you get that as your final answer. And the final one, 2 negative 1 and 1/3 negative 3. Okay, so again, x1, y1, x2, y2, the slope equals y2 minus y1 over x2 minus x1. So this is negative 3 plus 1, which is negative 2, and in the denominator we have 1/3 minus 2, so that's 1/3 minus 6/3. So I've changed 2 into 6/3. 1 minus 6 is negative 5, so you get negative 5/3. And again, the numerator is negative 2, which is negative 2 over 1. So you get negative 2 over 1 times negative, take the reciprocal of that, 3 over 5. So the reciprocal of 5/3 is 3/5. And the negatives cancel out, and you end up with 6/5. So that's your slope between those 2 points. So then we use the point slope form of the linear equation. So you get y minus y1 is equal to slope times x minus x1. So the left-hand side, this term becomes positive, and then you multiply the 6/5 out, so you get 6/5 x, and here you would get negative, because it's just one negative sign. 6 times 2 is 12, 12/5. Okay. Okay, so we need to solve for y. Subtract 1 from both sides. Get y is equal to 6/5 x minus 12/5 minus 1. I always go this one extra step. You might be able to do this in your head, and that's fine. But I put these on the same line, and then I convert this to the appropriate fraction that has the same denominator. And then I can just do the simple math. So negative 12 minus 5 is negative 17. So you get 6/5 x minus 17/5. Okay. How many more problems we got here? Okay, now the last bunch of problems, you're given a point and a line which you want to find the line that's perpendicular and parallel to the given line. So these are all the same kind of procedure, and instead of calculating the slope from the 2 points, you just have to figure out what the slope is based on the line. And the first thing you need to do is to put this in slope-intercept form so we know what the slope is. So we would subtract 4x from both sides. That would give us negative 2y is equal to negative 4x plus 3. And then we divide everything by negative 2. So that solves for y. Here we have negative 4 divided by negative 2, which is positive 2. And we get 3 divided by negative 2, negative 3/2. So this is the important thing. That's the slope. So any line that's parallel has a slope of 2, and any line that's perpendicular has a slope which is the negative reciprocal. So the reciprocal of a whole number is just the fraction. So I rewrite this as 2 divided by 1. So the reciprocal is 1 divided by 2. And because this is positive, this is negative. So now we just continue on with the, as we did before. Use the slope, point slope form, linear equation. So you've got the point right here, 2, 1, and the slope. So the parallel line is going to be equal to y minus x1, y1. Well, not minus x1, y1, but minus y1, which is 1. Slope is 2 times x minus x1, which is 2. So you get y minus 1 is equal to 2 times x minus 2. Multiply out the right-hand side. Add 1 to both sides. And you get that. Okay, so that's the equation for a line that's parallel. Now to find the one that's perpendicular, the only difference is that instead of using a slope of 2, we use a slope of 1/2. So you're going to have y minus y1 is equal to negative 1/2 times x minus x1. So you get y minus 1 is equal to negative 1/2 times x minus 2. All I'm doing in here is just removing these parentheses. Same over here. Then we multiply this out. Negative 1/2 times negative 2 is positive 1. Then we're going to add 1 to both sides. So you get y is equal to negative 1/2 x plus 2. So if we plot these two functions, they should be perpendicular to each other. So I'm going to do that. Just show you that I did it correctly. Hopefully I did it correctly. So 2x minus 3. So this is a graphing program that I use a lot. So you have 2x minus 3, and the second equation is negative 1/2 x plus 2. And I've done something wrong there. What is that? Oh, this is a typo. And so you can see they're perpendicular to each other. And this works because the scale gives me a square here. So these distances in the x and y direction are equal to each other as far as the scale. So you see I did it right, which is good. Now, the next problem is easy because you've got y equals negative 3. And the slope of this is 0. So any line that has 0 slope is just going to be equal to y equals something. So we're going to have y equals 0. That's the y value here. Okay. Now, perpendicular, that is going to be a slope. So the perpendicular of a horizontal line is what we would say it's undefined, or it's vertical. So this is going to be x equals something instead of y equals something. Vertical line is x equals something. So all we have to do is have x equal the x value of the point. X equals negative 1. That's tricky. And the last one is going to be more like the first one. So you've got 2, 5. It's already in slope-intercept form, so that's nice. So parallel lines to this line are going to have the same slope. And perpendicular lines are going to have the negative reciprocal. So again, this is 3 over 1. So here it's going to be negative because it's positive, negative 1 over 3. Reciprocal, you just switch the numerator and the denominator. So the parallel line has the same slope, but this point. So use the point slope form of linear equation. Here's x1, y1. So I'll write it out again. So we get y minus, I'm not going to put the parentheses in this time, y minus 5. The slope is 3, x minus 2. So you get y minus 5 is equal to 3x minus 6. 3 times negative 2. You add 5 to both sides. You get y is equal to 3x minus 1. Okay, so that's the equation of a line parallel to this line, same slope. Now for the perpendicular line, slope is negative 1/3, so it's the same point. We use negative 1/3, and still the same point. So we would get negative 1/3 x. And here we have negative times a negative is positive. So positive 2/3. And we add 5 to both sides. So you get y equals negative 1/3 x. And we get 2/3 plus 5. And 5 is 15/3. Multiply the numerator 5 times 3 and the denominator 1 times 3. So you'll get negative 1/3 x plus 17/3. So those are the two equations. So let's plot those. First one's pretty simple. 3x minus 1. 3x minus 1. The second one's a little more difficult. Worries me a little bit. Negative 1/3 x plus 17/3. Negative 1/3 x plus 17/3, and they should go through this point 2, 5. 2, 5. Let's just move it up a little bit. So you can see they intersect at this point, and they are perpendicular to each other. So that's good. So that's how it works. Find the slope of the original equation. If it's not in slope-intercept form, put it in the slope-intercept form. Write down what the slope of the parallel lines are. It's the same, perpendicular, negative, reciprocal. Then use these slopes and these two different slopes with this same point. Plug it into the point slope form of the linear equation. Solve for the equation so you can plot it if you want to. And that's it. So finally we have 3 more examples where I give you 2 points and I ask you to find the equation of the line in the slope-intercept form. So you're going to see problems like this on the test because it covers pretty much everything in this section. So the first step is to find the slope of a line associated with these 2 points. So I'm going to do this for all of them. I'm going to write out x1, y1, x2, y2. So remember the slope is y2 minus y1 over x2 minus x1. And then we go over here and read them and be very careful. So we have 3 minus 4, negative 2 minus 5. So that's 3 minus 4 is negative 1. Negative 2 minus 5, or negative 2 plus negative 5 is negative 7. And we always want to simplify this. If you get 2 negatives, just make that into a positive. So that's the slope. Once you have the slope, then you can use either one of these points, doesn't matter, inside the point slope form of the linear equation. So this is the point slope form of the linear equation. If you use the slope-intercept form, I'm not going to count that right. Okay, so use the point slope form of the linear equation. So you get y minus y1, which is 4, is equal to m, which is 1/7. And then you get x minus x1, which is 5. So you just plug in the numbers in, and then we have to do the manipulation to get it into the slope-intercept form. So we're going to multiply this 1/7 times each one of those terms. And then we're going to move the 4 from the left-hand side over to the right-hand side. So when we do that, the sign is changed. Then we'll rewrite that term in terms of the denominator of the fractional part. So we want to convert 4 into something involving sevenths. So you take 4 times 7 is 28. 28 sevenths. And then you can just simplify the two fractions. So 28 minus 5, or negative 5 plus 28, is going to be equal to plus 23 sevenths. That's your final answer. Okay, next one. Calculate the slope. Let's write them in here. x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. So y2 is 4. y1 is negative 4. x2 is 7. x1 is negative 2. So let's do this additive inverse of a negative number. So that's going to be the negative of negative 4 is, the additive inverse of negative 4 is positive 4. The additive inverse of negative 2 is positive. It's positive 2. Okay, so we're going to get 8 ninths. Okay, so that's our slope. So we get y minus y1, which is negative 4, is equal to 8 ninths times x minus x1. x1 is negative 2. So the first thing we want to do is both of these additive inverses of a negative number. I'm not going to multiply this out until I do that step. So it becomes that. The next thing we do is we multiply the slope times both terms. So 8 times 2 is 16, so we get 16 ninths. We move this to the other side. So that positive 4 becomes a negative 4. Then we convert negative 4 into ninths. So 4 times 9 is 36. So we get negative 36 ninths. And then we simplify. So 16 minus 36 is going to be negative 20 ninths. Another way you can think about this is 36 minus 16 is 20, and then you change the sign because the negative part is greater than the positive part. And the final one, let's go ahead and write in these. So we get the slope is equal to y2 minus y1 over x2 minus x1. y2 is negative 1. We subtract y1, which is 4. Take x2, which is 5. Subtract x1, which is negative 2. So negative 1 minus 4 is negative 5. 5 plus 2 is 7. So I replace this with plus 2. So we can then use the point slope form of the linear equation. Y equals y minus y1 is equal to m times x minus x1. So y1 is 4. Slope is negative 5 sevenths. x1 is negative 2. So this one's don't have to do anything there, so I want to go ahead and take the additive inverse of -2, which is +2, then multiply this out. So 5 times 2 is 10. Don't forget the negative sign. -10 sevenths. We're going to take this -4 and we're going to move it to the other side. So this will become +4. And then we convert that to sevenths because that's the denominator. So 4 times 7 is 28, so that's 28 sevenths. And then we're going to simplify these two. So we get 28 minus 10, which is 18, so it's plus 18 sevenths. 18 sevenths. Okay, so that's probably the most important thing you're going to learn in this section, is those kinds of things.